Lesson 4. The Universal Pattern. Radical Regularity. If you learned SysML v1, you probably remember this feeling. Structural modeling made sense. Behavior modeling made sense. Requirements modeling also made sense. But they never felt like the same language. Blocks, activities, and requirements, though all technically classes in the metamodel, had distinct notations and diagram types. It often felt like learning 3 different languages. SysML v2 unifies them using radical regularity. Not by adding more constructs, but by removing the differences between them. And once you see it, most of the SysML v2 suddenly becomes predictable. This radical regularity is possible because SysML v2 applies one universal pattern across the entire language. Instead of switching mental models between structure, behavior, and requirements, you follow the same rhythm everywhere. Definition, usage, decomposition. You start by defining what something is. Then you describe where that thing actually appears in your system. And finally, you open it up and show what's inside it. So the pattern becomes very simple. Define something, use it somewhere, and then decompose it. And when you want to build hierarchies, you simply nest usages inside definitions. In the textual notation, this is done by simply using curly brackets. Once you understand this pattern once, you can apply it everywhere. To physical structure, to requirements, and even to behavior. So let's look at how this works in practice. We'll start with something familiar, a simple parts hierarchy. First, we define an engine. This line doesn't place an engine anywhere yet. It simply defines the idea of an engine, a reusable component type, like a blueprint. Now we define a car and say that it contains an engine. Here's what's happening in the model. Engine is a type. Car is another type. And my engine is a usage of the engine definition inside the car definition. So in plain language, this model is saying a car contains an engine. In SysML v1, this would span a block definition diagram and an internal block diagram. In v2, it's one consistent pattern. On top of that, the syntax you just saw is non-unique to physical structure. The same modeling logic can be applied to both requirements and behavior. Example 2. The requirements tree. Now let's apply the same pattern to requirements. First, we define a reusable requirement type. The vehicle must achieve an acceptable crash safety level. Just like before, this defines the requirement concept but doesn't apply it yet. Now we create a requirement set and use that requirement inside it. Here we're doing exactly what we did with parts. Safety limit defines the requirement type, and crash test is a usage of that requirement inside vehicle specs. This means requirements are now first-class modeling elements with structure, parameters, inheritance, and constraints, rather than just text strings. Notice that crash test automatically applies to the car subject defined in vehicle specs, because it is nested inside of it. Example 3, the action hierarchy. Now let's apply the same idea one more time, this time to behavior. This defines the idea of an ignition action. Now we define a startup sequence and include that action inside it. Just like before, ignite defines the action concept, and firespark is its usage inside the startup sequence. So again, we're not learning a new modeling rule for behavior. We are reusing the same definition and usage pattern we used for structure and requirements. If you step back and look at the 3 examples, the pattern is identical. A part definition contains parts, a requirement definition contains requirements, and an action definition contains actions. Different domains, same structural logic. This is what we mean when we say SysML v2 is fractal. The same modeling patterns repeats everywhere. Once you learn it, you reuse it across the entire language. So why does this actually matter? First, it makes the language easier to learn and easier to use. Once you understand the definition and usage pattern, you can apply it across structure, behavior, and requirements. You're not switching modeling styles anymore. You're reusing one consistent approach everywhere. Second, it makes requirements formal. Because requirements are structured like other model elements, they can own attributes, bind to specific system elements, and express measurable constraints. That allows tools to evaluate them rather than just storing text. Together, these changes make SysML v2 models more consistent, more analyzable, and far easier to scale. Here's a quick guide if you're mapping this to SysML v1. The key shift is that what used to be separate modeling concepts are now unified under definitions and usages. Behavior calls become action usages, requirement containment becomes structural nesting, and requirement text becomes both documentation and formal constraints. So the ideas are familiar, the language is just more consistent. Now that we understand the pieces and the regular structure behind them, the next question is how this looks in practice. In the next lesson, we'll explore the visual textual hybrid in SysML v2 and see how writing models in text doesn't mean losing diagrams. It means connecting them more tightly to the model itself.